Dear friends, I hope everybody will be fine. Today I will start with the new subject, Structure Analysis 1. If this video is useful for you, please subscribe to my channel for more update videos. Like, share with your friends. Let's start. I will start with the new chapter, Slope Deflection Method. Slope deflection method is used to analyze a continuous beam, frame without sway, frame with sway. But now I will start with the new topics, analysis of the continuous beam using by slope deflection method. This is A, B, C. This is the beam. Continuous beam we already discussed with the previous videos. Continuous beam is the beam which is have more than two support is called continuous beam. A, B, C, this is the two span of the continuous beam. But now here we will analyze of this type of continuous beam. A, B, one span, but the load is applied 40 kilonewton at the mid span of this AB. 20 kilonewton UDL load, uniformly distributed load is applied BC spine of the beam. Total AB beam is 4 meter, BC is 6 meter. But now we will start. First step number 1. Step number 1. First step is find the fixed end moment, considering all span as a fixed. But now we will find out fixed end moment. Moment fixed AB is equal to, if the load is point load, the formula is this one, minus WL by 8. 1 moment for this one. Moment BA is equal to fixed plus WL by 8. This is anti-clockwise minus, this is clockwise plus. Dear friends, you should know clockwise moment is positive, anti-clockwise moment is negative. As a assumptions, we considering clockwise moment is positive, anti-clockwise moment is negative. We have another formula for this one, WAB square by L square, and also minus WBA square by L square. This is another formula. But if the load is acting on the center of the beam, but the formula is this one, WL by 8. If the load is acting at the some distance little bit outside to the center or this side to the center, but the formula is WA square by B, WAB square by L square, WBA square by L square, moment of BA. Now we should find out fixed end moment at A. Now we wrote the formula, moment AB fixed is equal to minus WL by 8. Now just see here, W is the minus 40 into, what is the L? L is the 4 divided by 8. Now we will calculate the moment value of this one. I have calculator, we will calculate this one. But already I just calculated this one. 40 into 4 divided by 8. This is called 20. 20 minus 20. Minus 20 kilonewton meter. Now the moment of B A fixed plus WL by 8. 14 to 4 by 8 is equal to plus 20 kilonewton meter. Moment we find out fixed end moment of A. Now we will find out fixed end moment at a B. B is also finished. Now we will find out moment of BC at the span of BC. At the span of AB is finished. Now we will find out fixed end moment at the span of BC. If the load is UDL, the formula is this one, minus, two formula we have, minus WL square by 12. End moment BC is equal to plus WL square by 12. These two formula we have. According to the point load, this formula, according to the UDL load, we have this formula. Now we will find moment of BC is equal to minus W is 20 into L is 6 meter square divided by 12. Now I have already calculated, we have minus 60 kilonewton meter. Now moment of CB fixed is equal to plus 20 into 6 square divided by 12. Now this is also called plus 60 kilonewton meter. We calculated in the first step is calculation fixed end moment. First step is calculation of fixed end moment. Second step to find out right slope deflection equation. Consider displacement is unknown. Displacement, step number 2. Right slope deflection equation considering all displacement is unknown. Displacement is nothing but this one, theta and delta. These we have, one is the deflection, one is the displacement or rotation we have, or slope. These two types of unknown we have, considering this is unknown. Now we will find out final moment. For a final moment, first equation, moment of AB is equal to moment of AB fixed plus 2EI by L 2 theta A plus 2 theta B minus 3 delta by L. This is the equation. This is the equation we have. Now we will find moment of A B is equal to fixed end moment. We already calculated. Fixed end moment of AB is equal to how much? Minus 20 kilonewton. Minus 20 kilonewton. This one we calculated, this one we calculated, this one we calculated. Now we will substitute here fixed end moment. Minus 20 plus 2EI by L. What is the L? Span is 4 into 2 theta A. A is, dear friends, please you should know, if the beam is fixed, there is no rotation. But the angle is 0 here. The angle is 0 here. The angle is 0. This is 0. 2 into 0 plus 2 theta B, 1 theta B. Theta, this is a theta B. Theta B minus, there is no sinking, there is no deflections, no deflection. That's why this is also 0. 3 into 0 by L is 4. Now moment of AB is equal to minus 20 plus 2EI by 4 into theta b. This is equation 1. Equation 1. Now second equations. This is first, second equations. Moment of BA is equal to moment of BA plus 2EI by L to theta B plus theta A minus 3 delta by L. This is equation of second equation. We have moment of BA is equal to, what is the fixed end moment of BA? We already calculate 20 plus 20 kilonewton plus 20 plus 2EI. Now EI by 4 to theta B. This is 0, this is also 0. Now this is equation number 2. Equation number 2. Now third equation we have moment of BC is equal to, we have the formula moment of BC plus 2EI by L to theta B plus theta C minus 3 delta by L plus theta L by L. Now moment of BC is equal to fixed end moment of BC. Fixed end moment of BC is how much? Minus 60 to E. What is the I value? We got it here. BC value 2 I. What is the L? L is 6 meter. 6. Understood? Now to theta B. Theta C is also 0 because this is the fixed. Deflection is also 0. Now this is equation number 3. Equation 3. We have, I will write here equation number 4. This one I will remove. We already discussed. Now. Equation number 4. Moment of CB is equal to fixed end moment of CB plus 2EI by L to theta C plus theta B minus 3 delta by L. Moment of CB is equal to fixed end moment of CB. We already calculated plus 60 plus 2EI. I we will substitute 2I by L is 6. Theta C is 0. This is also 0. Now theta B. This is equation number 4. These 4 equations we have. According to these four equations, we will calculate the final moment. These 4 equations we got it. Now we will calculate the step number. We have step number 3. Step number 3. Using equilibrium conditions to find out final end moment. Consider this is the joint B, because joint B is connected to the span of BC and BA. Consider this is the joint B. At the joint B, we will calculate joint B equilibrium condition for the support. Summation of step number 3. equilibrium, using equilibrium condition, using equilibrium condition. Using equilibrium condition. Now summation of moment of B is equal to 0. Joint B we have two moment of fixed, BA plus BC. This is equal to moment of BA plus fixed, moment of BC fixed. These two, this is the equilibrium condition according to this equation. This is equation number 5. From equation 5 we will serve to find out final end moment. We will substitute moment of BA plus moment of BC. What is moment of BA? Moment of BA, the equation is this one. The equation is this one. Now let's we will do something. This 2 4, this is cancelled. What is the equations? 20 into EI by EI into theta B. Now moment of BA fixed, moment of fixed equation is this one. What is the equations we have? Equilibrium conditions, this one. Moment of BA is equal to this one. Moment of BC is equal to this one also. We will 4 this is 4 by 6, 2 by 3. We will consider this one. Now we will substitute BA value. BA is this one, 20 plus EI into theta B. EI into theta B. What is the plus this one also? Plus BC value is this one, BC value is minus 6, minus 60, 2 by 3. This one is a 4 into 4 by 3. Because we cancel this one, 4 by 6, we cancel 2 by 3, 2 by 3 into 2. That is called 4 by 3 plus 4 plus this one 4 by 4 EI by 3. What is the equations? This is also theta B. This is the equation 6. Now this is equal to 0. Equations 6 is equal to 0. Now we will find out the value of theta B. I already calculated. Theta B is equal to 17.14 by EI. This value I already calculated. Now this value, theta B value, we will substitute in equation this one, and also this one. We will find out the final moment. Now we will substitute moment of A, B is equal to, what is the equation? The equation of moment minus 20 to EI by this one. This is the equation 1. Minus 24 by 2 by 4 EI theta B. Theta B we will substitute the value of here, minus 20 plus, we'll cancel 1 by 2 EI. What is theta B? Theta B 17.14 EI. This EI cancel. What is the moment of AB? I already calculated. Moment of AB is equal to minus 11 minus 11 minus 11.43 kilonewton meter. This is the value of moment of AB, final moment. Now moment of BA is equal to, what is the equation of BA? The equation of BA is equal to 20 moment of 20. What is the equation? This one. We have 20. This is the EI theta B. Now we have 20 plus EI theta B. What is theta B? We will substitute theta B, the value of 17.14 by EI. This EI cancel. Now the value of moment of BA, I already calculate moment of BA is equal to moment of BA is equal to 37.14 kilonewton meter. This is the final moment of BA. Now we will calculate final moment of BC value. What is the BC? The equation of BC is this one. Man is 60, 4 by 3 minus 60 plus 4 by 3 EI theta B. Theta B we will substitute the value of 17.14 by EI. I already calculate this, so theta, this EI cancel. Now we will, I already calculate moment of BC is equal to minus 37.14 kilonewton into meter. Now we will find out CB value. I will remove this one. So look at here, dear friends, moment of CB is equal to, the equation of CB is this one, 60 plus, this is also 4 by 2 into 4, 2 by 3 EI. What is theta B? We will substitute theta B 17.14 EI. This is the value. Now this one is a cancel. EI cancel. What is the final value of CB? Final value of CB is equal to 71.42 kilonewton meter. This is the value of CB. We calculate final moment. What is the final step? Final step is final bending moment. We will find out final bending moment diagram. We will calculate it. Now I will clean this board. We will find out final moment is also calculated. We will draw the bending moment diagram. For the bending moment diagram, we will draw here the bending moment diagram. Just once observe the board. All values I wrote. I will clean this board. Step number 5 is to draw the bending moment diagram. Draw the bending moment diagram. Step number 5. Step number 5, find the step 5. Find the bending moment. Find bending moment diagram. Bending moment diagram. Free bending moment diagram plus end bending moment diagram. In bracket I will write down free bending moment plus final or end bending moment. End bending moment. That is the step number 1 is due to the point load, one is the due to the UDL. Now for the point load, what is the formula? WL by 4. WL by 4 for the point load. For the point load, the formula is equal to WL by 4. This is the final bending moment diagram due to the free. For the second is for the UDL load, uniformly distributed load. What is the formula? WL square by 8. These two formula we have. For the one is the point load formula, one is the for the UDL due to the free bending moment and end bending moment. One is the point load, one is the UDL. Now we will find out first. For the first equation, WL by 4. WL by 4 AB. W into L by 4 mean W is the 40 into L is the 4 divided by 4. This is called 40 kilonewton into meter. This is the due to the point load. We got it. Now fourth is the due to the UDL. WL square by 8. W into L square by 8. This one BC. For the AB we got it point load. For the BC we will due to the UDL. W is the 20 into L square is 60 divided by 8. Now we got it how much? 90 kilonewton. 90 kilonewton into meter. This we are do according to the point load, according to the UDL. That is the moment. Now we will draw the bending moment diagram here. Now we will find the bending, we will draw the bending moment diagram. First A, second B, C. These three support we have. Due to the point load, the load is acting on the center point here. That is the 40 kilonewton meter. Next, BC is the UDL. Due to the UDL, the bending moment diagram will be like this one. 90 kilonewton meter. This one. Now we will find out end bending moment according to the final end bending moment diagrams. Now we have moment of AB is equal to minus 11 point here, some here 11.43 we have. In BA we have 37.14. We have this one. Now this will be joint. This will be joint. CB we have this one. This one. That will be 71.1. 71.24 42. Sorry for that one. Now we will join these value also. This one, sum this one. This is the bending moment diagram. This is the final step. Now that is the positive, negative, this one. See, this is the final moment, bending moment diagram.